This is for resistors in parallel, and the resistors I chose do actually not include the 100 ohm resistor, which means that as I use these here, and I only have 3 of these, I have to put them in parallel, just like that, for example. So just click 2 of these resistors in here. There, and here we go. And they're actually in parallel. If I actually wanted to click one in there that would be in series, well, I would hook it up into these 2 springs here, but that's just on the side. Anyway, so now I got 4 resistors here, and I want to make sure that I use the right ones. So I'm just going to measure. I actually unhooked this here for the moment so that I can determine what resistance I have here. 149, so that's my 150 ohm resistor, and actually I have to measure it anyway, so I'm going to type it in here. 149 should be 150 according to the color code. The other one according to color code should be 240, and let's see, I got 242. I hope my arm is not in front of that. And then the other one I have here is 246. So those are 2 that should be the same, but of course 240, but within tolerance they're just slightly off. And then the 4th resistor that I have is 473. According to color code, it should be 470, but here it's 473. Okay, so those are the 4 resistors. Okay, then I'm going to put them all in parallel. There is the switch. And there we go. Okay. Now the switch is in the off position. Now I have them in parallel with each other. Notice I could have connected them here as well, but there's a certain reason for doing it over here and bridging it over to this particular lead, and that is when I measure the currents later, it's going to be much easier the way I have it arranged. Oh, I have to connect my single resistor from earlier. Put it into the spring, hopefully. Okay, great. Now, both disconnected. There's one, and here, maybe the other one. Oops. Sorry. Sorry that I do this here. Zooming out at me. Okay, now I hopefully got it. There we go. Okay, the camera turned off on me, so now I don't know how much it recorded. In the meantime, I was able to hook them up here, and my switch is in the off position, so I just go as usual for the resistance across here, and I measure a total resistance of 59 ohms. And when I look at any of the other numbers, I possibly could not come up with 59 ohms. Perhaps the only thing I can notice is that the 59 ohms for the total resistance is less than any one of the other resistances. Okay, let's turn the switch on and measure the voltages. voltage across the first resistor. Change those volts here. Voltage across the first one, 2.92 volts. Again, disregard the negative. Next one, 2.91 volts. Either way, 2.91. And across the third and the fourth. And I could take these singly apart here, but it really seems like they're all the same here, 2.91 or 2.92 volts. And then it says the total voltage would be, well, anywhere here, also 2.91 or 2.92 volts. Yep, there you go. I'll write down 2.91 volts for the total. So, with that one, I already conclude that the voltage across any resistor is the same in parallel, no matter where it is, which makes sense because they're all connected on the same side here to the same lead to the same side of the battery, so the voltage here should be the same. Okay, for the current, so I'm gonna turn this over here. In this case, actually, notice that the total resistance was only 60 ohms, so I may want to put it a notch higher to 200 milliamps because it may just measure more than 20 milliamps this time around. I'm going to start out measuring the total current, which is I disconnect this one and of course put the ammeter at this point here inside the circuit, so that's 48.9 milliamps. And that was the total current. For the 470 ohm resistor, comes out to 6.1 milliamps. For the one of the 240 ohm resistors, it comes out to 11.8 milliamps. Again, we disregard the negative. We connect, and now I have to take it out here anyway, and have to measure this one here. This is the other 240 ohm resistor, and I come out with 12.0 milliamps, which is virtually the same as 11.8 because the other one was the same kind of resistor, just with intolerance a little bit off. Okay, and now I have to see, because I had already trouble up, they're totally disconnected now. Because now it's the other one that I want to measure. Okay, now I have them totally disconnected again. This could be the same kind of problem like before. Okay, there's one, and this time around, fortunately, I only need one. There we go. Okay, 240 ohm resistor is connected, and now I go in here to measure the 150 ohm resistor, which gives me 19.4 milliamps, and with that I can also conclude something, and that is that the resistor with the least amount of resistance has the largest current going through. So that saying about that electric current takes the path of least resistance is indeed true. The other numbers that I see on here are definitely computations, so the measurements for the parallel here are done.